best of all review, we're going to look at quadratics and hopefully variations. So, quadratic functions, what is the function family?
Y equals X.
Well, okay, so these are called quadratics, and the equation is y equals x to the what?
Square.
Good. Remember, power of 2. If your biggest exponent is 2, that is a quadratic. Now, do quadratics have asymptotes? What?
No, ma'am.
Yes, they do.
Stop. None of that today.
You said at the start of
Stop.
class.
Yes, it does. Wait, no.
No asymptotes. Remember, asymptotes only for rationals, right? Well, that's when it was introduced. So, domain. Anybody remember or know the domain?
Yeah.
Good. So I'm gonna put a star on this because the domain is always negative infinity to infinity, just like the absolute value function that we looked at last class. Absolute value is a sharp B, right? What does a quadratic look like? A parabola, which is a U. Really, the end behaviors of both of those are probably going to be the same, right? I mean, so the domain, yeah, the similar shape. Domain is also the same. All right. So now, what about the range? Let's graph this parent function, y equals x squared. So, like we did last time, you could set up a table, right? I'm going to go put it in the calculator. Put in the y equals, put x squared. Okay? And if I graph it, if I hit zoom 6, just in case any of my windows are, weird.
That makes it standard.
Yeah. So that is what my graph looks like. I can go to second graph, go to my table, get some points. Usually 3 points to the left of and to the right of 0, right? Okay, so then if I go and graph this, I have 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. Should we do 3, 9?
Yep.
Perfect. Good.
Is it okay if you just hand did it and it doesn't look exactly right then?
Alright, so what is the range here? Start from the bottom. Where does this graph start?
0.
At 0. Good. At y equals 0. All the way to what? Infinity. Good. So 0 to infinity. So infinities always get parentheses. This 0, what kind of a circle do you have? Good. Because it's a closed circle. Good job.
Would you not have the packet?
So now, what about the zeros or the x-intercepts? Where?
0, 0.
At 0, 0. Good. Oh, look at the zeros and x-intercepts. Okay, same thing, right? So I'm going to just put an x there because it's the same as that. Right? Yeah, you could. I mean, well, why do we have it twice? I don't understand this. What happened? All right.
Make sure that you know it's
Yeah. What is the y-intercept? 0, 0. Okay, so now we're going to look at increasing and decreasing intervals. So the same thing that we did when we looked at the absolute value. You see how your graph changes direction here at the vertex, right? So I drew a vertical line through that vertex. What x number does this line go through?
0.
0. And then you have an arrow going to the left to negative infinity. You have an arrow going to the right to infinity. So look at the graph from the left to the right. What is this graph doing from negative infinity to 0? It's decreasing. And what is this doing from 0 to infinity? It's increasing. So again, increasing and decreasing intervals, we always use parentheses, no brackets, okay? So 0 to infinity for increasing, negative to 0 for decreasing, yes? Do you have a question?
Yeah, so there's no x-intercept?
No, you know what, there is. It's the same as zeros. That's why what I'll do is forget it. I'll just do, yeah. I don't know why we have it twice. It's the same thing. 0, 0.
Do you feel like it's
is there we go.
Yeah,
All right.
we're good.
Okay, so end behaviors. So remember how we talked about the end behaviors as x approaches infinity. That means the right end behavior. So what is your right end behavior doing? Hmm?
It's going
What, up to infinity, yeah. So as x approaches negative infinity is talking about the left end behavior, and the left end behavior is also going up. All right? So any questions about this? All right. Are we okay? Can we go on to the next one? All right. So some other polynomials. Okay. Cubic. Cubic has a degree of what? What is the biggest exponent you'll see? Yeah, 3. So cubic function could be y equals x cubed, or it could be y equals negative x cubed, right? It could reflect. If your biggest exponent is 3, then that means that the maximum number of terms that this could have is what?
2.
2. Good. So a cubic function is kind of interesting though. It could look like that, which doesn't really have any terms, right? So this is the parent function. But it could also look like this. And we could put a smaller graph next to it just to kind of show. Right? Isn't that also a cubic function? Because you have 2 places where it turns. Alright? So this one is important to note. So what about a quartic function?
4.
Good, 4. Y equals x to the 4th. So that means 3, maximum of 3 terms. So this is the one where it looks like an M or a W. Right? You have 1, 2, 3 terms. And then what's a quintic function?
Yeah,
5. Y equals x to the 5th. So then that tells me the maximum number of terms for that one is 4.
The double W.
1, 2, 3, 4. Okay. 1, 2, 3, 4 terms. Alright. Any questions?
So basically it's the
Not terms. Terms.
Yeah,
Alright. Questions about this? Alright, there are some tips for you. Beware the properties. Alright, first off, do we know this? Domain and the increasing and decreasing values, all x values. Check, right? Range and end behaviors are looking at what? Vertex. That's the same as finding what? The maximum and the minimum on your calculator. Or, I mean, I guess just whatever on your graph, right? But your vertex is going to be the same as your maximum or your minimum for quadratics and absolute value. If your graph touches the x-axis, right, but it doesn't cross through, remember how we talked about it just bounces off? Then that's a double root. It means you have 2 solutions there. Yeah, you guys have learned this. If it wasn't true, why would it be here? So you can use the calculator to find the zeros, the max, or the min. Remember, this is where you use blinking Bob. All right? And, you know, where you go to get that a second trace, right? Which is calc. And then there's an option for 0, minimum, and the maximum. All right, so a couple of examples here, pictures. All right. So number 1, on the SOLs, you may see a problem like this. Place points on the x-intercepts of this graph. Can I just tell you guys something? I want all of you guys to pay attention, okay? Listen to me. So you guys have taken the math SOL before, yes?
Yes.
Okay. So do you remember how up at the top they give you all of those tools? So there's like an eraser, there's a highlighter, right? So one of the tools is this. It's just a little dot. I don't know, but it's a dot. So do not use that dot for problems like this. Placing points on something on your graph, don't use that dot. To be honest with you, that dot is useless. Don't use it, okay? In order to actually place points on the graph, all you need to do is just take your mouse cursor to the point and just click on it, and a dot will appear. Does that make sense?
Yes.
Do not use that dot because it doesn't register as an answer. Okay? It just registers it as you didn't answer it. All right? So, with that being said, where are the x-intercepts of this graph?
3, 0, negative 3, 0.
Negative 3 and
2, 0.
2 and negative 1.
Oh, yeah.
Good. So there are 3 places that you should click on your graph to show the x-intercepts. Okay? And then number 2 says, indicate the intervals where the graph of that function is only increasing. Only increasing. If you wanted to use your tools, all right, you could use your highlighter, highlight increasing, right? This I would put in the calculator. Go to your y equals, put this in. Everyone should be doing it. Don't just watch me. So everyone should be doing this.
I have a problem with my calculator.
Why?
I don't know what this is.
So you have this graph, right? You know, don't get stressed out about, well, I can't see the whole entire graph. You may not even need to, okay? Let's see what we have as our answer choices, okay? So increasing, well, we know that this is technically going down, right? And this is going up, okay? And another way that I know that this is going up on the right is because my leading coefficient, right, is a positive number. That means that my right end behavior is going up, okay? So when I look, it's increasing from here to wherever the heck it stops up here, right? So that is probably going to be halfway-ish, what I can think. And think, you know what, maybe it's like here. Okay? All right? Just what I'm thinking, all right? So it's probably increasing from negative infinity to, I don't know, between 0 and negative 1. And then it decreases here, which I don't need. And then at 1, right, from 1 to infinity is also increasing.
That's 2.
Oh, the 2, I'm sorry, 2 to infinity is increasing. So if I look, where is it only increasing? Here. And then here. Right? All right, enjoy your lunch. So the next problem, choose all of the graphs that have a domain and a range of all real numbers. So let's go through domain, range. You know what? Since it says choose all of the graphs that have a domain, right? Then that means, you could have more than one answer. So, I'm going to look at this and I'm going to go, okay, what doesn't have all real numbers? Right? Which one doesn't work? So, if you look at every single one of these, the domains, they're all real numbers, right? Because you have an arrow on the left, an arrow on the right, right? It means that it's going from negative infinity to infinity. So let's rule out the ones that have a range, or that don't have a range of all real numbers. If I look at letter D, see how both of these arrows are going down? So it's coming from negative infinity, but where does it end?
Negative infinity? Oh.
6. So that's not going to work because the range is not all real numbers. Look at C. C has it has two terms here. However, you have an arrow going all the way down. Where's that going? Negative infinity, and then you have an arrow going up to positive infinity. So C works, right? Domain and range are all real numbers. Does B work?
No.
No. Does A work?
Yeah.
Yes. So A and C are your two answers for this one. How about this? Choose all of the following graphs that increase along the interval -3 to -1. Okay, increasing interval is which values? X's or Y's? X. Good. So that means that -3 and -1, those are both X values. So -3 here, say like -3 to -1. Right? So from -3 to -1 for A, is it increasing your graph? Yeah. So that one works. -3 to -1, does that one work?
Mm-hmm.
What do you mean no? From the left to the right. This one works, it is increasing. -3 to -1. What about this?
No.
No, because the graph is decreasing. And what about this?
Yes.
-3 to -1. Yes. So you have 3 answer choices here. Questions about this? All right. All right, so the next one, the graph of y equals x squared minus 6x plus 8 is here. What is the vertex and the axis of symmetry? First of all, where is the vertex?
It's 3, -1.
Good. 3, -1. Right?
So we can get rid of
So
B and
3,
D.
-1, that means B is out, D is out.
C.
Is what? C?
C.
Why is it 3 and not -1?
Because your axis of symmetry is your x pointing the vertex.
Good. Everyone got that? 3, -1, x, y. And both of these already have the x equals, right? Wouldn't it make more sense to say x equals 3, the x value, instead of x equals -1, which is the y? Remember, axis of symmetry is x equals the x number from your vertex, okay? Which describes the end behavior as x approaches negative infinity. Which arm of the graph? The left one. What is the left end behavior doing?
Approaching infinity.
Good. Perfect. It's B. It's going up to infinity. All right, so let's look at some factoring. All right, so there are 6 types of factoring here. GCF, factoring by grouping, which is 4 terms. T-chart, when you have 3 terms, right, the AM way. And there's an x squared in the front. So the next one, they call it soccer, is the swing one. So you can cross that out. I think we've been calling it swing. This one's a swing AM. All right. The next one is difference of squares, which is, difference of squares, which is a dose. Right? 2 terms and perfect squares. And then the sum or difference of cubes, which is, you can cross that out, this is a SOAP. Yes. This is a SOAP way. Same, opposite, always positive, okay? So, lots of factoring. Number 7, which is the factored form of x squared minus 18xy plus 81y squared.
C.
Guys, if it looks funny, like it's not just an x squared, x, and it has y squared, you can use the bring down the first, bring down the last, rewrite the one in the middle, use the grouping way, okay? So I heard C. All right, let's see, let's try this. So this is AM because this is a trinomial, right? Is there a number in the front of that x squared? No. Technically it's 1, right? But I don't need to swing anything over because 1 times another number would just be whatever that number is, right? So 2 numbers that multiply to give me 81, but adds to give me negative 18. What are they?
-9, -9.
Negative 9 and negative 9. Good. So that tells me bring down the first. Bring down the last. And then in the middle, you're going to rewrite that xy term using the 2 numbers that we found. So the 2 numbers are, what, negative 9 and negative 9? So minus 9xy minus 9xy. Okay, make sure you include the variables that are in that middle term. And then now that you have 4 terms, how do you factor this? Yeah, just divide it right down the middle. Don't cut through that negative sign in front of the 9, okay? And GCF factor both sides. Right? On the left-hand side, your GCF is an X. On the right-hand side, your GCF should be a negative 9y. Please make sure you bring out that negative. So I know I did this right because my parentheses match. So your matching parentheses go in one, and then your outside GCFs go in the other one. Well, there you go. X minus 9y times x minus 9y, which is x minus 9y squared. Good. Questions about this? All right, let's try the next one. Identify one of the factors of 54x cubed minus 128. Ooh, one of the factors. Well, you need to factor out everything, but your answer choice is not going to have all of your factors, right? So 54x cubed minus 128. What is the first step in factoring? GCF. 54 and 128. Do they have a GCF?
2.
Is it 2? Is 2 the biggest number that will divide evenly into both?
Yeah.
Yeah? We all agree? So I'm going to show you guys something, okay? On the calculator, you can also find the GCF, all right? So what you need to do is you have to go to Math, tab over to Number, and you see that option here for GCD is the greatest common divisor, all right? So your calculator likes to, doesn't call it the GCF. All right, and then you can only put in 2 numbers at a time, and they both have to be positive, okay? So we have 54. Make sure you separate it with a comma. Comma is right above the 7.
Right above the 7.
And then put in 128.
For 128.
I know. Thank you.
You're welcome. Why did you say it?
Just I know. Like, no. Sorry. Okay.
It's okay.
Then hit
Thank you.
enter. Yes. And Dylan was right. It's 2.
I know I'm right.
Oh, he knows he's right. Well, you know what? Not everyone had the vote of confidence in their faces when they were all looking at me.
That's
So 54 and 128. 54 and 128, the GCF is 2. So that means you take a 2 out of both of these, and what do you get?
27 and 64.
Good. So 27x cubed minus 64. Now, 27x x cubed minus 64, can you still fit?
Oh, yeah.
Yeah, they're all perfect cubes, right? So 2, right? 3x minus 4, 9x squared plus 6, right? Are we okay with that? Do you need me to go over how to get any of those terms? You need to say something, okay? All right, so just identify one of the factors. Well, which one is the only one? D. Okay? All right, number 9, choose all of the factors of 225x to the 6 minus 81y to the 10th. I really like this problem because this is very representative of the type of problems that you might get on the SOLs. Right? But it's not really. 225 and 81, do they have a GCF?
Yeah.
What is it?
3.
Is it 3 or 9? Oh, put it in the calculator. Ha!
Let's see.
Remember, you need the greatest common factor, okay? So 225 x to the 6 minus 81 y to the 10. So GCF is 9. So if you divide both of these by 9, what do you get? 25 x to the 6 minus 9 y to the 10. Yeah, right? Am I done here? No. Is it so or is it dose? Dose. Why? Because 25 is a perfect square. 9 is a perfect square. There's a subtract in the middle. Now, x to the 6. Guys, you can take the square root of even exponents. Okay? Because all you have to do to take the square root of x to the 6 is divide that by 2. Alright? You can take the square root of y to the 10th by dividing that exponent by 2. Okay? So now, yeah, remember doses, double parentheses, opposite signs, 5x cubed. Right? That's what I get out of the square root of 25x to the 6. And then 3y to the 5th. And don't forget to bring down your 9. Bless you. So what are all of the factors here? 9. The one right below that. And 1 next to 9. Yes? What is the factor of that expression? You should be able to do this one, right? They're not asking for all, they're just looking for one. You know, this is an AM situation, but you have a number in front. What do you need to do with that number?
Swing.
Good. Swing it and multiply. That gives you your new M. What is 6 times negative 3? Negative 18, and adds up to give you. So what are the two numbers? 9 and negative 2. Good. So the same thing. Bring down the first, bring down the last, rewrite the one in the middle using your two numbers. You have the answer? Good. What is the answer?
A.
Good. All right, so finding the zeros are the factors, right? Okay. So basically, to get a factor from a 0, all right, So a 0 is, let's just review this, okay? A 0 is when they tell you x equals something, right? That's your 0, right? To get a factor from that, you want to make it so that it equals 0. Right here. So in order to turn this into a factor, right now it's equal to 3, right? Make it equal to 0. How do you do that? You subtract that 3, right? So then it becomes x minus 3 equals 0. That's your factor. Does that make sense? And then you can get the 0 by making your factor equal to 0 and then solving for x, making it equal to x, right? So just going back and forth the other way. You know, as long as it's not a fraction, really, they're just opposites, right? If your 0 is a positive 3, then your factor is x minus 3, right? It only gets a little bit complicated if it's a fraction and you end up with something like 2x minus 3. So number 11 says the zeros of a cubic function are -1, -2/3, and 5. Select all of the factors. Well, these are all zeros. X equals -1, x equals -2/3, and x equals 5. How do you turn these guys into factors? Well, the first one is pretty easy, right? You can say is x what? Plus 1. And what about this last one? X minus 5. So it's just the fraction one that's a little bit odd. Yeah? Yeah. Multiply by 3 and then add the 2, right? Here's another way that you can do it, okay? I'm just going to show you, but if you don't remember it, just remember you're making this equal to 0, okay? So if you have x equals -2/3, right? To turn this into a factor, it would be x plus 2/3. Do you agree? Yeah? But you can't leave it as 2/3, right? So you want to take this 3. Oh, you can't see that. You want to take this 3 and you got to move it into the front. Okay? So then this becomes 3x plus 2. Alright? Still the opposite sign, but you take whatever's in the denominator and just move it and it becomes a coefficient. Does that make sense? It's the same thing if you were to make it equal to 0. Well, you could, I don't know, I'm going to add this. Times it by 3. So 3x equals -2, and then add the 2. So 3x plus 2 equals 0. That's your factor. Okay? Same thing. So then the zeros are, the factors are x plus 1, 3x plus 2, and x minus 5. Yes? Okay. Which is a real 0 of the function, that guy. They give you all of the factors, so what are the zeros? Well, this one. And these are all just mini equations. That's all you're doing. Just a regular x, your 0 is 0. What about x plus 2? What is your 0? -2. What about this guy? 5/2. And that one? 3/4. Right? We're just making each of those equal to 0 and solving for x. Well, then your answer is C. All right, questions so far? Okay, which number is the 0 of this? You know what? So, this has multiple choice. I know that I can factor it and then do mini equations and see what I get. Yes? So, I'm looking at my answer choices here. Okay, I have 12 and 4. I have some fractions. Sure. You know what I'm going to do is I'm going to graph this. Because it's the fastest way. I'm going to go into y equals. I'm going to put this in. I'm just going to teach you guys some test-taking strategies, all right? Because some things will save you some time. And then you can solve, you know, you can use some of your energy on more difficult problems. All right, so if I look at this, all right, those are my 2 zeros, right? All right, do I have 12?
Mm-mm.
Yeah, so is 12 gonna work? No. Is 4 gonna work? No. All right, well then, what is this? 12 over 7, is that one gonna work? Maybe, right? First of all, I don't have a negative 0 as one of my answer choices, so I'm not interested in the negative one, right? Let me see what this one on the right is. Well, is it 4, yeah, is it 4 over 7? Yeah, so it seems like it has to be 12 over 7, right? So here's my other way. It's just because I just don't want to factor. Look at all the stuff I have to do if I don't want to factor, right? I have to do 12 over 7, okay? Let's store it for x. Store for x. Right above on, store for x, okay? Now, you're telling the calculator, hey, anytime I put in x on this main screen, it means 12 over 7. So, put in your equation, 7x squared plus 16x minus 48. Hit enter. I get 0. That tells me it is a 0. So this one's good. Questions about that?
Do you have to do that for every?
No. Listen, if you like factoring, you can factor.
You can store for x.
Yeah, you can store for x. Listen, you can store for x for everything if you wanted to. If you can. All right, if you can. All right. The issue will be though if you store it wrong, or if you put something in wrong and you get the wrong answer. Well, then I can't help you. All right.
What if the answer just comes up?
Yeah, then that means that they know what tactics you can use, so you just have to be careful. They know what mistakes, you know, are commonly made. So for number 14, which value of x? Oh no, okay. For which value of b is x squared plus bx minus 60 favorable over the set of integers? Do you even know what this means?
No.
No, but you say D. Why? Did you do it?
No, I mean, kind of.
Kind of?
Yeah.
It's C.
So I hear D, I hear C.
I got an
What the
Wow.
heck?
Guys, this is what it's asking you. If you were to make a T-chart here, so two numbers that multiply to give you negative 60, and adds to give you, well, which one? 61, 23, negative 7, or negative 16? Which one of those works? Let's
C.
see. Is it C?
Yeah, it's the only one.
It's the only one.
You can't add to make any of the other numbers. I tried.
All right. Well, let's see then. What did you use?
negative 12.
Yeah.
Negative 12 and 5. That multiplies to give me negative 60.
Yes.
I could have used negative 10 and 6. What else? Negative 20 and 3. Or the other way around, right? And 2.
And 30.
30. All right. But anyway, you get the idea. You could have done negative 60 and positive 1. But when you do that, so then this gives you negative 7, negative 4, or the other way, depending on which number gets the negative sign, right? So then negative 7. Yep, so C. Questions about that? All right. So solving equations. All right. You know, it's a good thing that we actually did a quadratic formula problem during Stinger. So remember when you're solving quadratic equations, this is not for all equations, it's for quadratic equations. So you can use solving by factoring only if it's factorable. All right, you can't always use that.
That's what a quadratic formula.
Solve by the square roots, but you can only do that if you don't have that bx term. And you can use the quadratic formula, but only if, no, that's always. Okay. All right, what is the solution to the following equation? What did you do here? What did you get? Hmm?
Yeah.
You got D?
Yeah.
Does that work?
Yes.
Yeah.
Yeah. You know, you could use a store function here too. You could plug in each of those solutions if you had no idea, right? All right, but you can use the square root method. Whenever you draw the square root, you gotta put plus or minus. So this is x minus 3 equals plus or minus square root of 14, right? Does 14 break down? No, because it's 7 times 2, right? Add the 3. And remember, if you have a plus or minus already on one side, when you add or subtract the number, it has to go in front of the plus or minus. So then this becomes x equals 3 plus or minus the square root of 14. Which is D. What is the solution set of this equation? So, tell me something. Does it make sense to graph this? No. Look at all your answer choices. I mean, that's crazy. Even if you graphed it, you wouldn't be able to pinpoint. Yeah. No. So, looking at your answer choices, what is probably the best way to solve this?
Quadratic formula.
Quadratic formula. But, say you don't want to do the quadratic formula, but you could plug it in. You could use the store function here, too. All right? What? What's wrong, Isaiah? Why are you so surprised? So, what do you guys want to do? I'll use the store function to show you how to put in these fractions, but we could also do the quadratic formula. Yes.
There's something wrong.
Why? What's wrong?
Because the number under the quadratic, the root symbol should be 20 instead of 19.
Okay, so let's plug in A. Let's plug in A. So I have a fraction, but in the numerator, I have more than one term. That means I need to put parentheses around it, okay? So I'm going to put in parentheses, -4 plus square root of 19.
What about the minus?
No, you can't put in plus or minus at the same time.
Oh.
It just means that you have two. One is plus and one is minus. Okay?
How do you put another
Divided by.
I have a question. How do you put another parenthesis around the 19? See how you have two parentheses?
But that's because my calculator does that. Does yours actually go inside the root?
I just don't know how to make it close for 19.
When you hit square root, don't you get a open parentheses?
Yeah, but one side is closed, so I have to close the parentheses.
Yeah, so then you need two.
Then I just put another one.
Store for x, Dylan.
What?
Hit enter. You're going to get a weird decimal because that is what that one is, right?
Yeah.
So then you're going to do 3x squared plus 8x minus 1. And if I get 0, then I know that this one works. Plus or minus, both work. Okay? The issue is going to be if you put it in the calculator incorrectly, then you may overlook the correct solution. All right? But do you guys see how to put this in the store function? All right. All right, circle all of the solutions to this equation. All right. So the second one, you could use a sort function, but this one's a pretty easy one. X to the 6 equals 64. How do you get rid of the 6th power?
The sixth root.
Do the 6th root. But wait a minute, that's an even root, so what does it need? So x equals plus or minus.
2.
How do you put in the 6th root into your calculator?
5.
Yeah. In order to put in the 6th root, you have to do 6, put in the root, then go to math, and you see the 5th one down, the one with the little x in front of the radical, that one changes it to a 6th root of 64, so that gives you 2. So your answers are going to be plus or minus 2. Find,
2 and
find, yeah, find the discriminant of the function and then determine how many and what type of solutions you have. So remember, the discriminant is all of that stuff inside the square root in your quadratic formula, right? So that is b squared minus 4ac. You got to make sure you make it equal to 0, all right? So a equals 5, b equals -3, c equals 1.
Do you want us to only do that part or the whole entire thing?
What do you mean? They only said find the discriminant.
Okay.
So b squared minus 4ac. Do you see how I put parentheses around the b? You have to. Because if you do parentheses -3 squared versus not putting parentheses there, you're going to get two different answers. Okay? And we need this to always be positive. So what is this? Is it? Did I do it right? -11? So Louise, since we have a negative number as the discriminant, what does that mean about the type of solutions and how many? Does that mean I have real solutions? Oh, okay, so it's not real, then it's going to be imaginary, right? If you get a negative number as your discriminant, it means you have imaginary solutions, but how many?
11?
No, 2. All right, just to recap. If you get a positive number, you have 2 real. If you get 0, you have 1 real. If you get a negative, you have 2 imaginary. Yes? All right. Yeah? And it's actually written up at the top, too. Mm-hmm. Inside that, what's it, that dash box?
Yeah.
Okay. No, I mean, it's fine. Listen, it's a lot to remember. All right, so 18. As x approaches negative infinity, which of the following describes the end behavior of this? Okay. Guys, this was another thing that we looked at when we looked at polynomials. All right? So one of the properties, one of the characteristics of polynomials is that you can look at the leading coefficient and you can look at your degree to figure out what the graph looks like, okay? What it's going to do. So you have a left end behavior and you have a right end behavior, right? If you look at your leading coefficient, if that's a negative number, it means that your right end behavior is going down to negative infinity. Because that's negative, your right one is going down to negative, okay? But if I know that, how do I know what the left end behavior is doing? Well, then you look at your degree. This degree is a 7, right? Is that an even or an odd number?
Odd.
It's an odd. So an odd means that they do different things. And even means that they do the same thing, okay? So since this is odd, if your right end behavior is going down, then your left one has to be going up. So as x approaches negative infinity, which is your left end behavior, then your f of x is approaching positive infinity. Does that make sense? Yeah, so then like unit 4.
One more.
All right, identify all the points where the graph of that intersects the x-axis. Okay, graph it. If you look at all of your answer choices, I mean, they're all easily distinguishable from a graph. Or you could back it. I mean, it doesn't matter. Okay? You know that -1 is definitely, right? That's the first one. So -1, absolutely. What else? -4. And really, how many solutions do you have at -4? Two. This is a double root because it bounces off. It doesn't cross
That
through.
means that -4 is twice.
Yes. So -1 and -4. Oh, circle 1. Not good.
We're done.
No. So now we
We
have
don't have that.
variation. You should have
We
variation.
don't have it.
Wait, this is
Yeah.
All
All right.
Homework?
So let's look at variation. It's not
what
homework.
is the homework?
No.
What is
I didn't get it.
No, it says day 2, part 2. It doesn't say homework. So variation. All right. So some things you need to remember: direct variation, direct line. Think of it as a direct line. Y equals kx. Inverse variation. Y equals k over x. And joint variation is y equals kxz. It's the same as direct, but you just have more variables. Plus, please remember, all problems have a k. Constant of variation, it has to have a k. So let's look at the first one. Which equation represents the statement R varies inversely to S and directly proportional to the cube of t? All right, to start from the beginning, if you see the words varies, that means equals k. All right, so you have R equals k, but it's inversely, so I know it's going to be a divide to what? S. But it's also directly proportional to the cube of t. Does it say cube root? No. So it's cube of t. Alright. Questions about that? So the volume of a cone V, so they tell you the variable, sure, varies equals k jointly with its height h. Okay, so let me start writing this down. V equals k h. Since they said varies jointly, I'm expecting another variable, right? And the square of its radius. Guys, did it say square root? No, so it's r squared, right? If k is the constant of proportionality, which of the following equations represents the correct relationship between volume, radius, and height? Yeah? There you go.
Does it have to be in that order?
No, the thing is that multiplication is commutative, so you could change the order and it doesn't change, like, your problem. Right?
Mm-hmm.
So even though they listed it this way, and technically you probably should write out your equation this way, they just switched it around a little bit. Doesn't matter. Which equations represent this situation? A car stopping distance d varies, equals k. So d varies directly with the speed it travels, which is s, and inversely with the friction value of the road surface, f, so divided by f, right? So now this one's a good problem. It says, which equations, right? So the second one. So if you look at each of these, they're all solved for a different variable or different variables. So you need to take your original and see if it equals any of these other ones. So Yul said the second one,
And also the one next, the first two.
also the first one.
Yes.
All right.
Multiply by half.
Yeah. The second one is your equation. There's one that's df. Well, in order to make this df, you would have to multiply it by f. And then you have df equals ks. Great. Absolutely. Good job. So what about, is there any way to get d times k? No. Is there any way to get, no, this one doesn't work. How about ds? Is there any way to get d times s? No, because the only way to move this s would be to divide it, right? That doesn't work. How about this? How about k? Oh, you want to try it?
That would work.
Would it? All right, let's see. D equals ks over f. Let's try to solve it for k and see if we get that. Times f. So then you have df equals ks, and then divide by s. So k equals df over s. Oh yeah, that one works too. Okay? So these type of problems you will see on the SOLs because they're not going to give you just a regular old easy variation problem because they get that in Algebra 1. Alright? So you guys are in Algebra 2, they may give these. Okay? If y varies jointly with x and z, alright, so here we go. Y varies jointly with x and z, so y equals kxz. What is the constant of proportionality? What is k? When y equals 30. Oh my goodness, I want to say b.
B.
Yeah?
B.
Great job. Alright? Alright, questions? Okay, so the next one says, given x varies jointly with y and w, varies, remember, equals k. X varies jointly with y and w. So, this one is like a real, you have to go all the way through type of problem, right? So, this first part here, that is what helps you to find k. Alright? You have to do that first. X equals 20 when y equals 10 and w equals 2/5. 2, 4. So k equals 5. Right? And then they said, what is the value of x when w equals 8 and y equals 3/5? Well, now you need to rewrite your variation problem with the k that you found, because that is the link to their relationship. Is it 8? 3 over 15 times 8. X equals 3, 1, 8. Good. So x equals 8. And no multiple choice. Guys, this might be one where you have to type in the answer. Alright? Look at the next one. The amount of time. Oh, so this one, they didn't even give you the variables. You have to come up with your own. The amount of time required varies directly. Varies equals k. So I'm going to create my own variables here. T for time equals k. Directly with the number of people, so I'm going to say P. And inversely with the number of boxes over B. Yeah. All right, so remember, the first number information that they give you is what you need to use to find k. So 2 people can stack 60 boxes in 10 minutes. And you know what? Be careful of the units, all right? Because they're telling me 10 minutes here, and I hope they ask me for minutes later on, but what if they say like hours or seconds? I mean, that would be the worst, but. So then what is this? 60 times 60 times 60. 300 equals 2k. K equals
60? What?
300.
Divided by 2.
Okay.
60.
I multiplied by 60 on both sides first.
Yeah, so 60 times 10 is 600.
Oh, never mind. Use the wrong numbers.
All right. So K equals 300. So you need to take your original equation and now plug in 300. T equals 300P over B. So now, how many minutes you need to find T will be required for 6 people to stack 120 boxes? 15 minutes, only 15 minutes. Goodness, they are fast. There we go. All right, hard-working people. Kind of like the hard-working students we have in the room right now. Right, Dylan? Just say and Jose. All right, the number of, okay, the time it takes to do a job is, you know what, do this. You do this.
I already
Why am
did
I
it.
good? And if you already did that, then do the fence one.
I already did it.
All right,